Non-native Phragmites australis, or common reed, is invasive in the Great Lakes Basin, and controlling it can be expensive. Because it often isn't clear what management approaches will succeed, many managers are interested in science-based decision support. The Phragmites Adaptive Management Framework, or PAMF, invites Phragmites managers to contribute to and benefit from collective learning. At the core of the program is a mathematical model that weighs the same factors that you might consider when managing Phragmites: trade-offs between efficacy, uncertainty, and cost. It draws on experience and data from participants across the basin to determine the best value guidance for each management unit. Each complete set of reports that you upload to the PAMF Web Hub teaches the model about Phragmites' response to management. Monitoring reports track the severity of each Phragmites invasion through time. Management reports tell the model what was done and how much it cost. Together, these reports show the model how Phragmites in your management unit responded to the actions you carried out. PAMF's model keeps track of what is known about management outcomes by categorizing invasions into 6 states, increasing in severity from 1 to 6, and predicting how likely an invasion is to transition from one state to another after management. Imagine that you have a highly invaded management unit in state 6 and plan to control it using management combination A. Before you take action, the model predicts that your unit is 40% likely to improve to state 4, 20% likely to improve to state 3, and 10% likely to end up in another state. After managing, you see the unit's infestation improve to state 3. The model responds by increasing its prediction that similar units managed the same way will improve to state 3, and reducing predictions that they will transition to any other state. As you and others file reports, you add to the pool of data that informs the model's predictions. Now, suppose you have another combination available. The model predicts that combination B is 40% likely to improve your unit's infestation to state 2, 20% likely to improve it to state 3, and 10% likely to result in another state. Since combination B is more likely to improve your unit to a less invaded state, the model will recommend combination B over combination A, provided that it isn't too expensive. As the model collects data about cost and effectiveness of each of PAMF's 16 combinations, its guidance changes to reflect the best information available. You make this happen. The model is a critical part of the adaptive management process and reduces the uncertainty surrounding Phragmites management throughout the Great Lakes Basin. Your data drive the collective learning process and help reduce the spread of invasive Phragmites.